Okay, from here, linear equation. In the previous video, we've discussed homogeneous equation, right? Now, if we're talking about linear equation, are we together? When it comes to linear equation, the idea is very, very simple. Are you with me? All you need to know about linear equation. When you're talking about linear equation, you should consider this guy here, integrating factor. Meaning, there's no way you'll be talking about linear equation that you'll be referring to what integrating factor. Consider this differential equation. How do I know that I'm using linear equation? Generally, linear equation in differential equation is written as dy over dx plus p y equals to what? Q. Where p and q are function of x. Where p and q are function of x. What we are saying is that p a function of x, meaning real number 1, 2, 3, 4, 5 and the likes. Similarly to q. Now, doing your comparison, we already established the fact, or you already know that when we have a differential equation of this nature, it means what? Linear equation. Abi? Now, comparing this and this, what can you say about them? This and this, what can you say about it? They are the same, Abi. Yes. This is dy, this is dy. We said p is a function of x. What will be the value of p here? 5. We said y, this is y, this is y, Abi. Q is also a function of x. What will be the value of q here? Exponential 2x. You understand? So that's what we are saying. Now, but we said when we are talking about linear equation, we'll be referring to what? Recall, well, we said when we are talking about linear equation, we'll be referring to what? Integrating factor. Now, take note of this. The integrating factor is equals to exponential integral of p. Are you with me? We need to get your integrating factor in any given question. To get your integrating factor, this will be the formula. Call this 2. And call this 1. Any differential equation of this nature is referred to as what? Linear equation. When you've concluded that it is a linear equation, then your integrating factor comes in. Then this is the formula for integrating factor. Exponential integral of p, where p is a what? Function of x. Right? Now, let's solve this. This is a linear equation, Abi. First thing first, identify which one is your p, which one is your q. Now, what is the function of p here? P of x is what? 5. And q of x is what? Exponential 2x. The next thing is to get the value of the integrating factor for this question. Meaning, for this question, integrating factor is equals to what? Exponential integral of what? 5. Right? Okay. Integral of what? 5. Applying integrating factor to this question, we have exponential integral of 5. We know where 5 is coming from. Why? Because p is a function of x and it is 5 in this case. So let's integrate this. Call this 1. Let's integrate 1, meaning the integrating factor. Now, what you should do is that bring out integral 5x. Exponential is constant or true. For every linear equation, you have your exponential. Now, let's get the value of integral 5. The integral of 5. We are saying that integral of 5 is equals to what? What will be the integral of 5? 5x plus what? C. Meaning, for this question, the integrating factor is equals to what? Exponential 5x plus c. That's it. You understand? We get there. Okay, from here, From here, what you do is multiply both sides. Multiply both sides. Don't let me introduce my c yet. Multiply both sides by, don't introduce your c yet. Multiply both sides. Your integrating factor, multiply it by the given equation, the original equation. Let's call this original equation A. We are saying that we are multiplying the value of the integrating factor. And what's the value? Exponential 5x. We are multiplying exponential 5x by the original equation. Multiply it by the left hand side. Also multiply it by the what? Right hand side. Meaning, you have that integral of 5x, open bracket, dy over dx plus what? 5y equals to what? Exponential 5x times what? Exponential 2x. What was the first thing that we did? We identify if it is a what? Linear equation. Hence, if it is a linear equation, get the value of what? Integrating factor using this formula. Abi? And in this case, this is my integrating factor. Having getting your integrating factor, the next thing to do is to what? Multiply the integrating factor by the what? Original equation. Multiply by the left hand side of the original equation. Multiply it by the what? Right hand side of the what? Original equation. And that's what we are doing here. Then from here, that will be what? Exponential 5x dy over dx equals to what? Equals to what? 5, sorry, plus, okay, let's do it this way. 5 exponential 5xy, abi, equals to what? Exponential 7x.
Yes.
This time this, 5x plus this. Okay, let me show it. Exponential 5x plus 2x. That's what? 7x. But from here, let's keep this. We are coming back there. There's something I want to show us. From here, let's differentiate y and exponential 5x. This is, I've multiplied both sides by the original equation using the integrating factor. Abi. Yeah. Now let's keep this. Stop here. Let's call this equation 2. Let's call this equation 2. Let's keep equation 2. I'm coming back to equation 2. But before that, let's see this. From here, applying the knowledge of differentiation. Whenever I have this question, it means what? Product rule. Abi, where this is my u and where this is my what? V. And what do I know about product rule? I know that when it comes to product rule, the formula is what? U dv over dx plus what? V du over what? Dx. Now, substitute the value of u and v. Okay, from here, I didn't know u, I didn't know v. Let me get the v dx. From here, the v over dx will be what? That will be what? 5. What you just need to do, we call your differentiation. When you have something of this, the v dx is what? 5 exponential 5x. From here, I didn't know the v dx. What will be the u dx? The u over dx will be what? Let's say we have u is a function of y, or let's say u is equals to y. Now, how do we get the u dx? From here, the only way we can get the u dx is to differentiate both sides with respect to x. Then by doing that, we have u differentiated with respect to x, we have what? The u over what? The x. Abi, equals to y differentiated with respect to x, we have dy over dx. So we are saying that the u dx is equals to what? Dy dx. Then we have dy over. Alright, substitute the respective value of u, the v dx, v, and the u dx. We have that u is equals to what? Y. The v dx is what? As 5 exponential 5x plus v is what? Exponential 5x. Then the u dx is what? The u dx is what? Dy over dx. Now, call this equation 3. From equation 3 and equation 2, what can you say about both equations? They are what? Okay, let me rearrange equation 3 as exponential 5x dy over dx plus 5 exponential 5xy. What can we say about equation 3 and equation 2?
Both of them are equal to real percent.
Both of them are what? Both of them are the same. Then how do we got this? We got this by saying y times what? Exponential 5x. Meaning I can substitute this whole equation 2 as what? Y exponential 5x. You understand the logic? Now, when we got here, we said we stop here, right? Considering y times exponential 5x. Applying the knowledge of product rule, we end up getting the same thing we have here, right? Meaning equation 2 is what? The same as what? Equation 3. Now, my question is, how do we arrive at equation 3? It was the derivative of this guy that gave us this, Abi. Meaning that the derivative of y exponential 5x is the same thing as equation 2. Substituting this, we have that the derivative of this, with respect to x, of what? Y dot exponential 5x is equals to what? Exponential 7x. Don't forget, all this is to get y. From here, cross multiply. Hello, are we together? By the time we cross multiply, the y will come to this side. We have that d open bracket y dot exponential 5x equals to what? Exponential 7x dx. From here, integrate both sides. Integrate both sides. By the time we integrate both sides, you have d open bracket y dot exponential 5x is equals to what? Integral exponential 7x dx. From here, integral can cancel this. Can cancel this derivative. Abi, this cancel this. Meaning that y exponential 5x is equals to what? Integral exponential 7x dx. Now let's integrate the right hand side. Y exponential 5x is equals to what? That will be exponential 7x over what? 7 plus c. From integration, when you integrate the right hand side, this is what you have. Meaning integral exponential kx is equals to what? Exponential kx over k. That's the knowledge. Okay? From here, don't forget, all you are doing is to get y. The only way we can do that is to divide all through by exponential 5x. Then we have y exponential 5x divided by exponential 5x equals to exponential 7x divided by 7 plus c 1 over exponential 5x, right? Then from here, this cancel this. We have y equals to what? Exponential. Okay, from here, we have this cancel this. We have exponential 2x, Abi, equals to exponential 2x over 7 plus what? Exponential plus c over what? Exponential 5x. This as 1 over exponential 5x, we multiply this. We also multiply this. By the time we multiply this, you'll be left with this. And by the time you multiply this, you have this. Then writing this in a nicer way, we have y equals to exponential 2x over 7 plus c exponential minus 5x. Then this is the function that was differentiated. Hence, you are done.